In this tutorial, I'm going to talk about the types in Julia. I start with two claims. The first one is Python is a dynamically typed language. And the other claim is Julia is an optionally typed language. Julia can also be considered a dynamically typed language. But what does that mean? Julia is actually a dynamically typed language, though if you specify a type like variable, double colon type, you can think of that variable as being statically typed, and this will improve performance in cases where the compiler couldn't automatically infer the type. Actually, what is the definition of the type? Data elements come in different shapes and sizes, which are called types. Consider the following numeric values. For example, a floating point number, a rational number, an integer. These three different types of numbers, and in general, in different data types, can take different amounts of memory in the computer. The type of function gets the concrete type of x, and x is passed to the type of function. For example, type of 0.5 and type of the rational division of 1 divided by 2, and type of the integer 1. For example, the type of 0.5 is float64, the type of 1 rationally divided by 2 is rational int64, and the type of integer 1 is int64. Basically, it's easy for us humans to add these numbers without much thought, but the computer won't be able to use a simple addition routine to add all three values. Over here, for example, the integer and the floating point number and the rational number. Because these are different types. Code for adding rational numbers has to consider numerators and denominators, whereas code for adding integers won't. The computer will probably have to convert two of these values to be the same type as third. Typically, the integer and the rational will first be converted to floating point, then the three floating point numbers will be added together. Actually, this business of converting types obviously takes time. So to write really fast code, you want to make sure that you don't make the computer waste time by continually converting values from one type to another. When Julia compiles your source code, which happens every time you evaluate a function for the first time, any type indications you've provided allow the compiler to produce more efficient executable code. Another issue with converting types is that in some cases you will be losing precision. Converting a rational number to a floating point number is likely to lose some precision. The official word from the designers of Julia is that types are optional. In other words, if you don't want to worry about types, and if you don't mind your code running slower than it might, then you can ignore them. But you'll encounter them in error messages, the documentation, so you will eventually have to tackle them. A compromise is to write your top-level code without worrying about types. But when you want to speed up your code, find out the bottlenecks where your program spends the most time, and clean up the types in that area, you'll have to know about the types. The typing system, there is actually a lot to know about the Julia's type system, so the official documentation is a place to go, but here's a brief overview. Here's the Julia's type hierarchy for the number types. In Julia, types are organized in a hierarchy with a tree structure. At the tree's root, we have a special type called any, and all other types are connected to it directly or indirectly. Informally, we can say that the type any has children. Its children are called any subtypes, and a child's supertype is any. As you can see, we have a good example of Julia's type hierarchy as you're looking at the number types in Julia. The type number is a direct child of any. To see what number's supertype is, we can use the supertype function. For example, we can type supertype number and see the value of it in the Julia's repo. But we could also try to find numbers subtypes. Numbers children, therefore any's grandchildren. To do this, we can use the function subtypes. We type subtypes number and we'll get the numbers children. And we can observe that we have two subtypes of number, complex and real. For mathematicians, real and complex numbers are both indeed numbers. As a general rule, Julia's type hierarchy reflects the real world's hierarchy.